Alright, so I asked you guys to do this problem 2x squared minus x plus 12 divided by x plus 3 in 3 ways. Class, what's one of the ways? Long division. Let's do long division first. I'm going to put x plus 3 over here, 2x squared minus x plus 12 over here. Class, how many times is x going to 2x squared? 2x. Multiply 2x times x. 2x times 3. 6x. Make sure you use these parentheses. When you subtract now, 2 minus 2 is negative 1 minus 6. Negative 7x. Bring down 12. X goes into negative 7. How many times? Negative 7 times. Now let's multiply. Negative 7 times x. Negative 7x. Negative 7 times 3 is negative 21. (12 minus negative 21) 33. Class, is x plus 3 a factor? Yes or no? No, not a factor. Because there is a remainder. Okay, what's the other way?
Long division. Synthetic division.
Synthetic division. Whoops, wrong way. Try that again. Just do it like this. What number goes on the outside?
X plus 2. Wait, no, wait, what?
Do we put positive 3 here? No. X plus 3 equals 0. This is a factor. To make it a 0, you subtract 3. Set it equal to 0. You get x equals negative 3. So you should put negative 3 here. Class, what numbers do I put on the top? 2, negative 1, and 12. What do I do first? Bring it down. What do I do next? Multiply. Add down. Multiply. Add down. Your answer is 33. So hopefully you see a pattern that so far each of our methods has told us what the remainder is. Class, using synthetic division, is it a factor? No, not a factor. Because there's a remainder. Alright, this is our last method. This was yesterday's lesson. Yesterday's lesson we had 2 theorems. One of them was called it's this blue thing, the remainder theorem. Remainder theorem. What does the remainder theorem tell us? It basically says this number, although they gave us x plus 3, the factor, if I take x equals negative 3 and I put it into my function here, and every time there's an x, I can write what now? I'm going to write negative 3. Every time there's an x value, right, from up here, we're putting in a negative 3. Let me zoom in for you. So again, this is trying to recapture or connect all of these ideas. Putting in negative 3 here. This basically says, what are you putting into your function? So if that distracts you, you can just cover it up. Class, should I multiply or do exponent? Which one, class? Exponents, right? PEMDAS. Think of PEMDAS. So negative 3 times negative 3. Positive 9. Opposite of negative 3? 2 times 9. 18. 18 plus 12 plus 3 gives me 33. We see 33 again. Let's answer the same question. Is it a factor? No, not a factor, because there is a remainder. Alright, so long division, synthetic division, remainder theorem, all can get us the remainder. Basically, we learned a faster way of finding the remainder is you can just substitute it in. Now, what's this bottom part called? We've been asking the same question for a long time, and this was at the end of yesterday's lesson. They call this the factor theorem. Everyone say factor theorem? Basically says that if there's a remainder, it's not a factor. It's a factor when your remainder is 0 or there is none.